you have under PDA types of PDA. One is a top-down PDA and the other is a bottom-up PDA. First, we shall is a top-down PDA. Okay, now you all know what do you mean by top-down and bottom basics. Maybe you all have seen your subjects. So here in top-down PDA, what we do is start by putting the start symbol grammar onto the stack. Okay. Now usually we know that the grammar starts with the S as a start symbol. Okay. So the first job here is to put S on the stack. Now the second task here after pushing S onto the stack is to carry out the derivation which is carried by the context-free grammar. Okay. So for that we will be having two types of move. The first is to replace a variable that is A on top of the stack. Okay, so whatever are the productions of A, you can put on the stack. The second is to pop up the terminals from the stack. Now you all know that these are the basic operations which we perform using a stack. Now these things will be clear to you and example. So now this is a grammar which is there in front of you. The context-free grammar, except languages with strings having more than beats. You can read it from this language which is given. So the total number than the total. So for that, we write this context-free grammar. This will be given to you. You all have to design a top-down PDF. So let's check out, start designing a top-down PDF. Okay. Before going ahead with this, I will be directly displaying the working of the top-down PDF. Okay. Now you all can see this particular string which is present over here. You all can interpret these things by now. So the string which is given to us here is a valid string. It has is and it has A's. So obviously the number of A's are more than B's. Okay. So at first state, you one state. Take the entire string which is given to you. And now you can see on this left hand side, by default, the stack contains Z0 as the initial element. So what is the first thing we do is, you all can see the grammar here. We push S on the stack, okay? We have pushed S on the stack. You all can see how we have written it here, SZ0. The first step is done. Now the second step is be in the same state. So now here, instead of S, what we are doing is we are replacing the derivation. Okay. There was a network problem. I repeat. Okay. We are replacing S in terms of one of the productions. So this is what was told in this step. Replace a variable A on top of the stack by the right side alpha of some function A giving alpha. So now the step will be clear. So this S has been replaced by the production SB. Now this S, you can see another production here. S has been replaced with SBS. And now whatever S was present here, I'm using a production S giving. So after using production S giving A, wherever this S is present, I replace this S by A. So now we concentrate on the tab. You can see that A is present here and A has been encountered. So these are the stack containers. Now, since both are matching, you have elements. So putting out elements on the stack and also from the input, we are left with this. Okay? We are left with this. That is BBAAA, and on the stack we are left with is Z. Okay. Now the same technique will be applied here. Okay, this B and this B gets cancelled out. Okay, we are left with triple A's. Okay, B and triple A's. And here we are left with SZ. Now we'll be using a production BSS instead of S. Why we are using BSS instead of S is we have to pop out this element B. So we need a matching element to be encountered. So that is the reason we are using the production which starts with B here. So S is replaced by BSS. Okay. So once you'll see that B gets cancelled out here and we are left with triple A's and this two S and S. Now this S gets replaced by A. So this A gets cancelled out. We are left with two A's and one S onto the left. Okay. So let's go to the context-free grammar and check what production can be used. So now you know you cannot use just S giving single A because you have another A to be encountered here. Here you have a production AS. So we will be using that production AS here. This A cancels out. And then at last you can use S giving A. So at last you're left with empty. Okay, and the top of stack is Z. So this particular string, which is valid, has got the stack top to be Z note again. So this was a top-down PDA. You'll see you're started with element S, which led to a empty stack later. Now it will be easy for you to understand how to design a top-down PDA. So having checked that example out, you all can see here have a state Q initial, the input encountered the stack of Z node. Okay, so from there we pushed S on the stack by changing the state. Okay, so the next option is I write all the possible moves of the grammar here, but I remain in the same. You all have seen that A is encountered on stack top, input is encountered A, we had popped the elements out. Okay, so at the end from one, when you have an empty string and the stack top is Z naught, you're going to a final state Q. So Q naught is an initial state and Q2 is a final state. Okay, so this is how the PDA has been defined over here. So the definition, here are the possible states, the inputs of the stack encountered AB. Okay, and this is what in and out of the stack. So even S has been moved onto the stack. So you have to write S. And this is the accepting state. Okay. So this is the explanation for top-down